Hi, everyone. Good morning or good afternoon, depending on where you are in the world today. I'm very excited to talk to you today about something that's very critical to our infrastructure, which is secrets management. So, picture this: your team just launched a new project and everything is running smoothly until someone realizes they don't have access to a critical database. So a frantic Slack or Teams message goes out, followed by a last-minute request to update Vault policies. Meanwhile, someone else is just hard coding credentials because it's just for testing. This sounds familiar, right? Now multiply that by every new project or your organization or department spins up. So every time a new project comes in, someone has to manually provision a Vault instance, configure it, and ensure it's secure. And it doesn't stop there. Vault instances need to be maintained, monitored, and periodically upgraded to keep up with security patches and new features. The more projects you have, the more overhead, security risks, and bottlenecks you face. Managing secrets manually is like playing a whack-a-mole. So when you think you've got it under control, another issue pops up. So how do we break free from this kind of chaos and be able to scale our management tools effortlessly? That's what we're here to talk about today. So in this session, I will show you how we automated the creation of vault instances for every project, so reducing overhead and improving security and making secret management scalable. So okay, so let me quickly introduce myself. My name is Umaima. I am a DevOps engineer specializing in automating infrastructures and improving the development cycle. And I enjoy sharing my knowledge with other tech enthusiasts, which is why I am joining you here today. So big thanks to the HashiCorp team for the opportunity. Now, if you've been working in any environment where security is a priority, you'll know that managing secrets like passwords and APIs, like API keys and certificates, can quickly become a headache, especially when you're scaling across multiple projects. But we can make the entire process automated and making it more secure, efficient, and scalable. And that's exactly what we're diving into today. All right, so let's look at what we'll be covering in this session. We'll start off by a quick overview of the Vault, focusing on our use case. We'll set the stage for the use of HashiCorp Vault and the challenges we have once we're on scale and once it becomes a core part of our tooling platform. Next, we will introduce process orchestration and how process automation platforms can be useful in automating and standardizing such operation team procedures. And we will have some implementation examples, and finally, a summary of results and lessons or takeaways from this experience. So starting with the Vault overview, so this is a short or quick or simple diagram to show off the Vault diagram or architectural uses, depending on our use cases. So as most of you would know, perhaps through the previous talks, Vault is a secret management tool. It stores and manages access to sensitive data or pieces of information that are needed to log in and authorize with different services, like username and password credentials or a token to connect to an API. And we have two types of users or consumers who need those secrets to log in to services, whether they're human or system users. So we can retrieve them on demand from Vault. So developers, might be sharing a file to share credentials with new joiners, for instance, or we might have them stored as CI/CD variables. And now we have to worry about who has access to that settings section, whether in GitLab or GitHub. And by now we have secrets scattered everywhere, and this leads us to two main problems. First, we have no visibility in terms of who has access to what. And secondly, if a specific secret was compromised, we wouldn't even know that it happened. And even if we found out, we wouldn't know what leaked the secret in the first place. So was it a developer's environment, a server through pipeline logs? So it gets complicated with big projects, and they're scaling in all areas, whether it be team members or infrastructure and so on. So for the same reason, secret rotation will be a chore to use as well, and comes Vault to solve the challenges I mentioned before. So it provides encryption at rest and in transit, and all our secrets now would be centralized inside this vault. So we have also fine-grained access control, and on top of that, we have auditing. So we get detailed logs of access and changes of secrets all in one place. So to summarize this in a few bullet points, Vault helps with these main pain points for us. So manual secret management being not scalable because as our infrastructure grows, manually creating, storing, and distributing secrets for each project or environment can quickly become unmanageable and inefficient. So the more projects you have, the more tedious and error-prone this process becomes. And we can solve this by automating the management of secrets using Vault. So it allows you to dynamically create secrets and control access policies. This means that you can scale your secret management effortlessly without the need of manual intervention, making it much more efficient. It also helps with the inconsistent practices across projects. So when each project or team manages secret differently, inconsistencies arise, and the platform teams or DevOps engineers actually deal with the potential security risks and operational inefficiencies. So we would likely end up with different practices, tools, and policies for each project, and we should keep track of these, and it can become a nightmare. So using Vault, and which provides us with a centralized system of managing secrets, regardless of the project, we use the same platform with consistent and predefined policies for managing access to sensitive data, which ensures uniformity and security across all projects in our organization or department. And all of this goes under time-consuming practices. So manually managing secrets is prone to delays. So we kind of we waste so much valuable development time, and we slow down delivery. And so Vault again comes to help with these issues and improve or unblock development bottlenecks with less secret management tasks handled manually. All right, so everything is great. Now we've got our vault in place and all our secret management issues are solved, right? No more manual processes, no more inconsistent practices. We're good to go. Well, the ops team would definitely be silent on that one because while Vault has solved a lot of problems, it does not mean that the work is over. Sure, we are able to streamline secret management, but now we're looking at the challenge of actually deploying and maintaining these Vault instances across multiple environments. And it's not just about setting them up once and forgetting about it. We need to spin up new instances as our projects grow, make sure they're properly configured for each project, and then keep up with updates and patches because, as we know, Vault is not the only thing that needs regular updates to stay secure and efficient. Backups, restores, migrations, policy batch management, etc. So yeah, the real work just begins for the ops team. So to mention a few challenges at scale, let me walk you through the real challenges we face daily. So first, there is the sheer volume of work. Each project needs its own Vault instance, and no two projects are exactly alike. We're constantly provisioning new instances, managing different versions across projects and platforms, applying security patches, responding to urgent access requests. And then there is the resource constraint issue. So our team is not growing as fast as the number of projects we support. We found ourselves spending hours on routine maintenance, struggling to maintain consistent configurations, racing to keep documentation updated, and juggling emergency requests with planned work. So the complexity increases when you add compliance requirements. And each change needs to be tracked, documented, and audited, and it goes through compliance and security as well. So it became clear that manual processes wouldn't scale. Now this diagram shows our workflow before automation. Let me walk you through a typical scenario here. So when a new project requests a Vault instance, we manually review requirements, we allocate appropriate resources, we set up the instance, we configure policies and access controls, and then monitoring while documenting everything along the way. And for maintenance, we track version updates, we plan for maintenance windows, we apply updates manually as well, we update configuration, documentation, and same for migrations as well. And each step requires careful attention and is very prone to human error. And here comes process orchestration. For info, our teams already use business process managers for many projects, and this is one of its use cases. There are many open source business process managers like Activity, Cogito, and we use Camunda, which used to be an open source process automation platform that helps orchestrate complex workflows. So in the context of Vault, it allows us to automate all the operation tasks, starting from the creation and configuration of Vault instances, reducing manual workload, and ensuring that processes run smoothly and consistently. But you might be asking, why a business process manager? Well, it's not just about automating one-off tasks. It helps creating complex workflows. It deals and groups many platforms as well. It handles decisions and ensures everything happens at the right time in the right order. So in short, it's the kind of glue that keeps everything together, even as our infrastructure and projects scale. And here's where Camunda comes in. We identified key processes that could be automated. So instance provisioning using standardized templates, automated resource allocation, and consistent configuration, maintenance tasks with automated version checks, scheduled updates, for instance, and configuration management, and access control, policy deployment, user management, and audit login. So the goal was not to automate everything at once, but to target the most time-consuming and error-prone tasks first. Now we'll go through an implementation example. And I'm using this process model, which is a sequence of tasks related to deployment of Vault and processing for a project. So it uses various service tasks and gateways and events to manage the flow. We start with the request, of Vault creation, which initiates the workflow. So this service actually notifies the portal that a project is in the planned stage. And from here, it moves to an event-based gateway, which manages multiple possible paths in the workflow, depending on different events that occur. Briefly, it could be a cancellation, early failure, and this one actually loops back to the gateway. This means that the workflow reevaluates conditions and may proceed on new inputs. And then we move forward after a waiting period of time and eventually to the task-informed portal processing, indicating that the project is now in the processing stage. And we begin dealing with the Vault cluster process. So the task fill Vault cluster variable sets up the necessary variables for Vault. This is followed by the GitLab process deploy Vault, which is a sub-process that actually integrates with GitLab to deploy Vault itself through a pipeline using a few projects that we have with all deployment files for each type of infrastructure we're using. So it could be on-premise, it could be using a cloud service provider, etc. And after that, the flow reaches another decision point, which determines whether to continue with the process or handle a cancellation according to the deployment status. And if the deployment scripts are successful, we check the health of the Vault cluster. So we run an API request or calls with the task check Vault status. And if the Vault is up and running, the process moves on. And if not, we hit another decision point. So the timer event adds a delay for retrying, giving the system some time to be fully operational before moving forward. And once the Vault instance is ready, we proceed with get Vault secret from transit. This task retrieves the necessary secrets from Vault, which are then used in subsequent steps of the deployment or configuration processes. And we have like a force processing part that ensures that even if the Vault cluster is already deployed, the system can continue processing other steps or processes, which, for instance, here we have the GitLab sub-process for the backup deployment. So we actually kind of ensures that the process can adapt to different exceptions or conditions, like retrying a deployment when needed or continuing despite prior cancellations. This kind of retry feature for backup deployments can help us avoid stopping the entire process due to a temporary failure or interruption. So it allows you to retry only the backup part and continue on. And once all processes are done, automatic emails are sent to set projects contacts with information concerning the new instance with user guidelines, URL, method of authentication if defined during the request. And finally, the portal status is updated and to complete it, and the workflow is successfully finished. The scripts actually can be like Java code, because each task you see here is actually connected to a method. So we use mainly Java and some shell scripts, especially for the GitLab processes. So our automated workflow currently handles resource provisioning automatically, instance creation from templates, configuration and policy deployment as well. We monitor setup here, and we actually deal as well with version updates and patches automatically. And now we can trigger Vault instance creation based on predefined configurations and values given by the users and project teams. It allows us also to define these steps that are required to provision a new Vault instance without any manual intervention. And we ensure that each Vault instance is provisioned consistently, so with the same configuration, without relying on human input. So it reduces the risk of errors. So a few results and some lessons learned along this experience. The results have been pretty significant. So we have 7,500% reduction in manual tasks. If we estimate how many hours we needed to create those Vault instances and manage them, we actually saved along the way of 800 hours with automated workflows. So we actually work on new tasks instead of repetitive tasks. And we work on actually improving the platform and these processes instead of doing or running the same commands over and over again. We had 80% faster instance provisioning. We had 0 configuration drifts and 0 issues with our recent migrations, and also automated compliance reporting. Key takeaways from our journey. I would advise with starting with the most time-consuming process or tasks, and start building automation incrementally. Also, keep flexibility for unique cases, because there will be projects that are kind of an edge case or a special use case that will need manual intervention, or a team member that should do something manually or handle a task manually. And also make sure to document your automation processes, and business process modelers actually help with that, using the graphics and showing you which part of the process is actually currently running, or if any issue pops up. And also make sure to never compromise on security. So make sure to automate also patches and version updates as well. And now our team can now focus on improving the platform instead of just maintaining it. And these lessons actually help us create a more robust and sustainable and scalable platform for our developers. So that's it. I hope you learned along the way from our experience. And if you need any more information, we can connect on LinkedIn as well. Thank you very much.